Welcome everybody to Rational Expressions and Equations Lesson 6. So in Lesson 5 we looked at multiplication of rational expressions. Today we're looking at division of rational expressions. So I'm hoping that you remember dividing fractions. You used your keep, switch, flip. I don't know if you learned that in middle school, but I know they were teaching that for a while. So anytime you are dividing a fraction, you're going to keep that first one, the same orientation, 7/10, and then you're going to switch that divide into a multiply, and then flip the last fraction. So instead of 3/14, it's 14/3. And now we have a multiplication of fractions, which is really nice because we know that we just multiply the tops and multiply the bottoms, which is awesome. However, you can always, we know from the multiplying rational expressions lesson number 5, we can reduce things before we do this if we'd like to. So we have 7/10 we can't really reduce, and 14/13 we can't really reduce, but we have a 14 here and a 10 here, so we can divide both of those by 2. So that would become 7, and that would become 5. And then we don't have to reduce our fraction as much once we multiply. 7 times 7 is 49, and 5 times 3 is 15. And there you have it. The next example, we have 6/5 divided by 9/10 multiplied by 1/20. So we're going to keep, switch, flip the first one, 6/5, and now we're going to multiply 10/9 and multiply 1/20, and then we can do some reducing, especially with, first of all, the 6 and the 9 can reduce to, if we divide both of those by 3, then that becomes 2, that becomes 3, and then we can do the same thing with the 10 and the 20. We can divide both of those by 10, so that becomes 1, and that becomes 2. And now in the top we have 2 multiplied by 1 multiplied by 1. So that becomes 2. Then we have 5 multiplied by 3, which is 15, multiplied by 2, which is 30. And then we can reduce that to 1/15. What I didn't notice here, because we had to do one extra step of simplifying it at the answer, is that this 2 and this 2 could have canceled out, and then we would have ended up with 1/15. I didn't see that, but that's okay. You can always just multiply all the numerators together and all the denominators together and then simplify, and you'll get the same answer. But it's easier to simplify it before you multiply, I think, and then you have your answer in lowest terms. So it says here, we can extend this method to the division of monomials containing variables. Remember to invert the divisor and multiply, or that's remember to keep, switch, flip. Here, a note, at this stage, do not state the restrictions on the variable. It's a little bit different this time, so we're going to dive into that a little bit later. But for now, we're just going to practice our keep, switch, flip method, and then we will start looking into non-permissible values after this. So here we have 16a divided by 9b squared divided by 32a squared over 15b. So we can do our keep, switch, flip, 16a over 9b squared multiplied by 15b over 32a squared. And we can start canceling things out. I know I have 16/32, which is awesome. So if I divide both of those by 16, that becomes 1. That becomes 2, which is great. I can divide 15 and 9 by 3. So if I do that, that becomes 3, and that becomes 5. I have a b on the top and a b squared on the bottom, so I can get rid of that b squared and cancel that b out. Same with my a and a squared. Cancel that squared out and cancel that a out. So on the top now, I just have 1 times 5. That's it. So 5, and on the bottom I have 3b and 2a, which is 3 times 2 is 6, a, b. There we go. In the next one, we are going to use our keep switch flip idea. So I have negative 5xy cubed over 7x z cubed multiplied by 2z, that's a bad 2, there we go, over 15x, and then we're going to multiply negative 21, we're going to flip that last term here, over 10x squared y squared. All right, so now we have to do some serious canceling out, but we can totally do that. The first thing I'm going to do is maybe I will do the 15 and a 5, so that can become negative 1. And this can become, if I divide that by 5 and I divide this by 5, this becomes 3. Then I can divide my negative 21 and my 7. So if I divide both of those by 7, that becomes 1. That becomes negative 3. And then I can do the 2 and the 10 as well. If I divide them both by 2, that becomes 1. And that becomes 5. Now let's deal with the variables. So I have x over x right here, which is nice because those will just go away. It looks like I have 1 z term and 4 z terms. So it's 5 z terms in the top and 3 in the bottom. So I can get rid of all 3 in the bottom, get rid of 1 here and 2 here. It looks like I have 3 y's in the top over here and 2 over here. So I'll get rid of all of those and 2 of those. So I'm left with 1. It's a little bit messy, but we're going to keep track of it here. We have negative 1 y times 1 multiplied by negative 3 z squared. So in the top of our equation, we have negative 1 times 1 is 1 times negative 3, or negative 1 times 1 is negative 1 times negative 3 is positive 3. And then I have y z squared. In the bottom, I have 1 multiplied by 3x multiplied by 5x squared. So 1 times 3 is 3, multiplied by 5 is 15. And then we have x multiplied by x squared is x cubed. So I actually made a mistake here. Well, I didn't make a mistake. I just didn't simplify further enough or far enough because we see that this 3 and this negative 3 could have canceled. But it's okay if you don't do that because now I notice that in my answer I have 3 over 15, which can reduce to 1 over 5. So now my answer is y z squared over 5x cubed. And that's as simple as it goes. Awesome. So let's start talking about non-permissible values. So they use an example here. If we have a over b divided by c over d, where all of these are variables, then for the first term, a over b, the non-permissible value is that b cannot equal 0. In the second term, c over d, the non-permissible value is that d can't equal 0 because d is on the bottom. But when we do our keep switch flip, what happens is we end up switching that c and that d around. So now that c is on the bottom. So when we do that, we actually introduce another non-permissible value of c can't equal 0. So in the term a over b, or in the expression a over b divided by c over d, our non-permissible values are b, c, and d. So we'll go over a couple of examples here. So any variable which appears in the denominator at any stage in the simplification should be considered for non-permissible values. So here it just says state the restrictions on the variables in class example 2. So we just did these equations, but we're not going to resolve them. We're just going to state the non-permissible values. So as it stands in the first one, the only thing we need to worry about is b can't equal 0. And that's because that's our non-permissible value for that one and that one. But we also know that we're going to flip this equation around. So now our we have another non-permissible value of a can't equal 0. Hopefully that makes sense, because you will have to keep this in mind when we go into doing the full problem. In the next one, we see that we can't have x equal to 0 or z equal to 0, and that comes from that term right there. In this term, x can't be 0, which we've covered already, and in this term, z can't be 0, which we've covered already. But we're going to flip this whole term right here because it's a division. So if we do that, that means that this x is going to go to the bottom, so that can't be 0, which we've already covered, but y also can't be 0, so that introduces a new non-permissible value. Y can't be 0. All right, let's put this all together. So we've got two questions here. The first one in A is already factored, which is really great. So the first thing that we're going to do is state our non-permissible values. So you can see that x can't equal positive 2, negative 3, and then negative 3 for this one as well. Right? That takes out all three of those. But also we need to realize that we're going to flip this term. So this one's going to end up on the bottom. So that means that x can't equal negative 1. So now what we can do is we can flip everything. X plus 1, or we can flip the last term anyways. X minus 2 and x plus 3. And we're going to multiply. Now we're going to flip things. X plus 3 is in the top, and 2x plus 1 is in the bottom. So we can start doing our canceling just like we do with multiplication questions. So I have an x plus 1 and an x plus 1. I have an x plus 3 and an x plus 3. So now I can say that that's equal to, well, I just have an x in the top, and in the bottom I have a 2x minus 2. And there's your answer right there. Oh, whoa, I almost forgot one. Don't forget, x can't be 0 either because of this x right here. So x also can't be 0. Almost messed that up. So let's go to the next one now. I'm going to scroll over a little bit. This one's a bit bigger. We've got this whole term divided by this whole term. So if you want, you can rewrite it in a way that makes more sense for you. I like to see it written out this way, 3x plus 12. It's better for my brain. Divided by 3x squared plus 9x over x plus 4 all squared. So now that I see this, I can see that my non-permissible values are going to be, maybe I'll just put them over here for now and we can write them with the answers after. Actually, before we do our non-permissible values, we need to factor. I don't know what I was thinking. So let's factor everything. So the top left term, we can factor a 4 out, and we're left with x plus 3. In the bottom left, we can factor a 3 out, and we're left with x plus 4. That's all divided by, in the top term there, we can factor out a 3x, and we're left with x plus 3. And in the bottom, we're going to have x plus 4 times x plus 4. Now that things are factored, we can state our non-permissible values. So we have a lot of plus 4s in the bottom, so x can't equal negative 4. But we also know that when we flip this second term, that all of this is going to end up in the denominator, so x also can't equal 0 or negative 3. All right, so now let's flip. 4 multiplied by x plus 3 over 3 multiplied by x plus 4 multiplied by x plus 4 times x plus 4. And And on the bottom, now we have 3x, x plus 3. And we can start canceling things out because we have an x plus 3 and an x plus 3. We have an x plus 4 and an x plus 4. And we can say in the top now we have 4 x plus 4. And on the bottom we have 3 times 3, which is 9x. There we go. Simplified. We've got our non-permissible values and we're good to go. I'm going to go to do 2 more questions with you. Oh, hang on. Here we go. All right, so I'm not going to do this one over here, but we can go over that one in class maybe. I'll maybe make a note right now. I've got my sticky notes. I always say that we're going to do that and then I never do, but I'm going to make a sticky note right now in class, or maybe even whiteboard work. I want to keep you busy for a while. So let's look at letter A here. So we're going to go 4x squared minus 12x, all divided by x squared minus 9, divided by 7x cubed plus 7x squared, all divided by x squared plus 4x plus 3. So the first thing that I'm going to do is, you know what we should do? Let's just flip this first. We can factor first and then flip, or we can flip and then factor. It's not going to make a difference. So I'm going to flip that second term. And then I'm going to factor everything. So in the top left, I can pull out a 4x, and I'm left with x minus 3. In the bottom, that's x squared minus 9. That's a difference of perfect squares. So we can factor that into a difference of perfect squares, where x squared is x times x, and 9 is 3 times 3. And we have a plus and a minus. And then in the bottom right, we can factor out a 7x, and we're left with x squared plus 1. And in the, oh, it's an x squared. I was like, that doesn't make sense. Okay, so we can actually factor an x squared out, and that becomes x plus 1. There we go. Sorry about that, I just forgot. Or just my transcription error. So it's actually important as you're writing all these steps down to make sure you write all of the terms properly, because as you can see, it would have totally messed my answer up had I not noticed. The top right is a trinomial with no constant out front, the x squared term, so we can factor that by inspection. So 2 numbers that multiply to positive 3 and add to positive 4 is going to be x plus 1, x plus 3. Before we simplify, we need to state our non-permissible values. So in the first term, x can't equal plus or minus 3. And in the second term, x can't equal 0 or negative 1. But we also have to look at the terms up here because they were once on the bottom. So x can't be negative 3 or negative 1, but we've actually covered both of those. So we're good to go. Now we can just start canceling things out. So I have x minus 3, x minus 3. I have an x plus 1, x plus 1, an x plus 3, an x plus 3. I have an x and an x squared. So now what I'm left with is 4 over 7x. And that's it. That's not so bad. Last question, we're going to ramp it up even further. We're going to divide 2 terms that are adding and subtracting. So you can see in the top we have 10 over a minus 12 divided by 2a plus 1, all divided by 5 over a plus 4. So first thing we're going to do is, well, let's write that down below. So we have 10 over a minus 12 over 2a plus 1, all divided by 5 over a plus 4 over 1. We want to write these with common denominators. So I know that in the top, we're going to be writing it a multiplied by 2a plus 1. That'll be our common denominator. So that means what we've done is we've multiplied this side by a and this side by 2a plus 1 over 2a plus 1. So now in the top left, I have 10 multiplied by 2a plus 1 minus 12a. And then in the bottom, my common denominator is going to be a. And the only thing I had to do to get there, the first term already is a, but this one I had to multiply by a times a, or a over a. So now I have 5 plus 4a. I can simplify the top a little bit. That 10 is going to multiply through. I'm going to leave this bottom one the way that it is because we don't want it to be not factored. So now this is going to be 20a plus 10 minus 12a all over a times 2a plus 1, all divided by 5 plus 4a over a. And then we can simplify these like terms here. 20a minus 12a, which gives us 8a plus 10 over a 2a plus 1, all over 5 plus 4a divided by a. So I can rewrite that 8a plus 10. I can factor 2 out of that. So now I have 2 multiplied by 4a plus 5 all over a multiplied by 2a plus 1. And then it's divided by 5 plus 4a over a. So now we can flip that. Oh. Multiplied by a, and then we've got 5 plus 4a. It's an a. Cool. Now we need to state our non-permissible values. So let's scroll over a little bit. This is a long question. I can say that a is not allowed to equal 0, negative 1 over 2, negative 5 over 4. And then we have to take into account that one as well, because that used to be on the bottom, right? This a used to be on the bottom over here. So a can't be 0, but we've already covered that right there. So we don't have to worry about that. Now we can get onto our cancellation. A over, or maybe I'll use blue. A over a cancels. 4a plus 5 and 5 plus 4a are the same, so those are going to cancel. And what we're left with is 2 over 2a plus 1. And that's it. We're done. That's awesome. Thank you for watching. Don't forget to like and subscribe.